We've said many times in this class that the structure of molecules is what's ultimately going to lead to their function. And we're finished with protein structure now, so it's time to move on to protein function. In fact, that's our first goal for this chapter, is to describe how the structure of key proteins leads to their function. There are about 20,000 proteins minimum in the human body and hundreds of thousands more in nature. So we have to pick just a few that we're going to talk about. And just very briefly, we're going to continue talking about myoglobin and hemoglobin. More on that in just a second. We're also going to go on and talk about a few other proteins. This is a strange looking protein. It's quite different than anything we've seen before. It's called collagen, and it's found in your skin and bones. And we're also going to talk about a protein like this, which is a membrane channel for potassium. So we'll come to those later in the chapter. For now, let's tell you what the second goal that we have in this chapter is. It's really going to be focusing mostly on hemoglobin and myoglobin. And we want to explain how the structure of hemoglobin and myoglobin allow directional transport of oxygen in lungs and tissues. Here's a biochemist's view of the circulatory system. It's not very impressive, but you probably know that oxygen is going to come into your lungs through your breath, and it's going to hop into arteries and go out to tissues throughout the body. It does so by jumping onto the protein hemoglobin in blood. That is what's going to be the transporter of oxygen in blood. That's what makes blood red. And it's going to hop off hemoglobin and out of the blood into muscles and tissues, and it's going to be stored there in myoglobin. So just briefly, to give you a sense of where we're going, we can define hemoglobin as oxygen transporter in blood. And myoglobin, MB, as oxygen storage in muscles. Okay, we'll pick up these topics on our next video.